Greatest common factor and lowest common multiple. Greatest common factor, lowest common multiple, GCF, LCM, what are they? How can I keep them straight and understand what they mean? In this video, I'm going to explain them and show how to use them in two different ways. The first way is a longer one to carry out, but it's more explanatory, while the second way is shorter and more practical, but less explanatory. We'll start with the greatest common factor and use 10 and 25 as an example. We must first determine the factors of 10. 1 is always a factor of any number. The next factor is 2, since it divides evenly into 10 to give 5. So 2 and 5 are factors of 10. There is no other number that divides evenly into 10 except 10 itself, so 10 is the final factor. Let's write them out in order like this. Now we find the factors of 25. 1 is a factor, and 5 is 2, since 5 times 5 is 25. The last factor is 25. Again, line them up in a row. Now, we can quickly see that the factors common to both 10 and 25 are 1 and 5. The greatest one is clearly 5. So GCF equals 5. Let's do one more example with 24 and 42. The factors of 24 start with 1, then 2, which divides into 24 12 times, making 2 and 12 factors. 3 divides evenly to give 3 and 8 as factors. 4 and 6 are factors. The last one is 24 itself. Let's line them up in a row and do the same thing for 42. First 1, then 2 and 21, then 3 and 14, then 6 and 7, and lastly 42 itself. We line them up and look at the common factors. 1, 2, 3, and 6 are all common factors to both numbers, but the greatest of these is clearly 6. So GCF equals 6. This is the longer way of determining the greatest common factor, but it clearly shows what we mean by the term. Now let's consider the lowest common multiple and use the same numbers, 10 and 25. We now look for multiples of 10, which means we're going to multiply 10 by 1, 2, 3, 4, 5, etc. These multiplier numbers are each multiplied by 10 to give us the multiples, but instead we could also just keep adding 10 at a time to get the same multiples. The 3 dots, of course, means this can continue however long you want. Let's get the multiples of 25 using either the multipliers or just adding 25 each time. Note that these are multiples of 10 and 25. They are not factors of 10 and 25. Now, which of these multiples are in common? Here, 50 is a common multiple to both these numbers. Are there any others? Here's another one, 100. So we have here 2 common multiples, and there are more if we continue the series, but we're interested in only the lowest one. Clearly, it has to be 50. LCM equals 50. Let's do one more using 24 and 42, the same numbers as before. Multiples for 24, the multipliers. Here are some of the multiples of 24, and here are multiples of 42. We now compare where they are in common. We have 168 in common, and that's the only one here. LCM equals 168. Any other common multiple will be greater than this and therefore of no interest for us. Sometimes the lowest common multiple is called the least common multiple. The lowest common multiple is the smallest number that both original numbers will divide into evenly. When adding or subtracting fractions, the lowest common multiple is used as the common denominator. If, for example, when adding 3/10 and 9/25, using the lowest common multiple of 50 looks like this, and the final answer is obtained immediately. However, just multiplying the 10 and 25 together will give a common denominator that can be used. Here it is using 250. The difference is that one or more simplifications to the final answer may be needed. In the second example, the common denominator would be 1008. It's your choice whether to do the work of finding the LCM or do an extra step of simplification. Now let's look at the shorter way. It is done by creating factor trees. Let's go back to 10 and 25 again. We can factor 10 into 2 and 5, and factor 25 into 5 and 5. Since 2 and 5 are prime numbers, we cannot factor any further. We'll do the greatest common factor first. Now, notice that the number 5 is shared between the two numbers. There is no number common to 2 and the other 5, so 5 is the greatest common factor. Now for the lowest common multiple. We look at 2 and notice that it's the only 2 between the two numbers, so that has to be involved. And then we see 5 occurring once under 10, but twice under 25. We take 5 where it occurs most often, 2 times under 25, and combine it with 2. The 2 and the 2 5s are multiplied together to get 50, and that is the lowest common multiple. Let's try another pair, 24 and 42. If you know your times table, look for larger numbers that are factors of both numbers. For example, 6 divides into both 24 and 42. So we factor 24 into 6 and 4, and factor 42 into 6 and 7. See how 6 is common to both, and that's the only number that is shared between them. 4 and 7 do not share a common number. So the greatest common factor is 6. To find the lowest common multiple, we need to factor further until we have all prime numbers. 6 factors into 2 and 3, 4 factors into 2 and 2, and this 6 also factors into 2 and 3. Now all factors are primes, so this ends the factorization. When factor trees are extended until all prime numbers, this is called prime factorization. We start here and see that 2 appears 3 times under 24, compared to once for 42, so we take these 3 2s. 3 occurs once in either case, so we take one of them. And 7 appears once, so we will take that and multiply them all together, 3 2s times 3 times 7, and that gives us our lowest common multiple, 168. Now we can verify the lowest common multiple if needed. If we divide it by the numbers it came from, it has to give us a positive integer or whole number. We will take 50 and divide by 10. This gives the whole number 5. Similarly, if we take 50 and divide by 25, we also get a whole number. In the same way, 168 divided by 24 is 7. 168 divided by 42 is 4. Both are whole numbers, so this lowest common multiple is correct. Now let's look at a third example, 18 and 36, which you could try yourself first, and then we'll go on and do 3 numbers. We factor 18 into 2 and 9. We factor 36 with 9 and 4. GCF first. Notice that 9 is shared between the two of them, so that will be part of the greatest common factor. 2 and 4 are different, but 4 can be factored into 2's. So here we have another number that is shared. We combine the 2 and the 9 to give the greatest common factor of 18. Let's determine the lowest common multiple. On the left we have a 2, but under 36 we have 2 2's. So we take these 2 2's and the 1 9 from either number, multiplying them together gives us the lowest common multiple of 36. Now I'll do this again to show how you can factor differently and still get the correct values. I'll factor 18 into 6 and 3 this time, and factor 36 into 6 and 6. 6 is common to both of them, but note that 3 and 6 have a common factor. It's best to complete the prime factorization. Notice that 3 is common to both numbers, so we must combine 1 3 and 1 6, which gives us GCT of 18, which agrees with the previous method. For the lowest common multiple, we continue prime factorization. We see that we have 2 3s under 18 and 2 under 36, so we take 2 3s. We have 1 2 under 18, but 2 of them under 36, so we take the 2 2s. Now multiply the 2 3s and the 2 2s to get 36 for the lowest common multiple. This agrees with the first method. This shows that there is more than one way to do the factoring. Finally, let's look at these three numbers, 12, 15, and 20. Factor 12 into 4 and 3, 15 into 3 and 5, and 20 into 4 and 5. Greatest common factor, notice 4 is shared, so is 3, and so is 5. Since they're all shared, they must be multiplied together to form the greatest common factor of 60. For the lowest common multiple, we continue to factor until we end up with all primes. Now 2 appears twice under 12 and twice under 20, so we take 2 2s. 1 3, which appears only once under 12 and 15, and 5, which also appears only once under 15 and 20. Multiplying them all gives us the lowest common multiple of 60. Now, for a neat shortcut to find the lowest common multiple, I'm going back to this previous slide to use these numbers. What you do is multiply the numbers together and then divide by the greatest common factor, which is usually easier to determine. 24 times 42 divided by the greatest common factor of 6 gives 168, which agrees with this. Let's do it again here for 18 and 36. Multiply the numbers 18 and 36 and divide by the greatest common factor of 18, and that gives us 36, which agrees with this. So that's a trick to keep in mind. It will work with 3 numbers as well. Multiply all 3 of them together, divide by 60, and we end up with 60 again as before. Finally, I will show 2 problems that make good use of these 2 concepts. These problems are essentially the ones taken from the Khan Academy, but I'm showing a slightly different way of presenting the solutions. Mary bought a package of 21 binders and a package of 30 pencils. She wants to open the packages and combine binders and pencils into sets for her classmates. The question is, what is the greatest number of identical sets she can make using all the supplies? What type of question is this? Is it a greatest common factor problem or a lowest common multiple problem? A clue is in the word greatest. This suggests that we're looking for the greatest common factor. So we're looking at numbers 21 and 30. We'll do the factor tree method. 3 and 7 for 21, 3 and 10 for 30. The 3's are common, and there is nothing in common between 7 and 10. So 3 is our greatest common factor. What does this mean? Mary can make 3 identical sets. What can she put into each set? 21 binders divided by 3 sets will be 7 binders per set. And similarly, 30 pencils divided by 3 sets will be 10 pencils per set. Problem 2. Teacher A gives 30 questions on each test. Teacher B gives 24 questions on each test. Both teachers say that by the end of the semester, all students will get the same total number of questions, even though they will take a different number of tests. The question is, what is the minimum number of questions that all students can expect to get? What type of question is this? Consider the key word minimum, which suggests that we're looking for the lowest common multiple. So let's find the lowest common multiple for 30 and 24. 30 factors into 6 and 5. 24 factors into 6 and 4. We have 6 as a factor that's common to both, and there is nothing common between 5 and 4. So 6 will be our greatest common factor. For the lowest common multiple, let's use the trick that was previously shown by multiplying the 30 and 24 together, dividing by the greatest common factor of 6, and that gives us 120. What does this number mean? It means that all students can expect to get 120 questions, even though they may write a different number of tests. I hope you now have a good sense of GCF and LCM.